Hello everyone, good day! So I am your Sir Nestor Arrespondo Jr. and I will be your math teacher for this year. So welcome to my online learning and I hope you are going to enjoy my class. So let's get started. So our first topic is all about sets. So before we proceed on our topic, it's good to know first our objectives. So the following are our objectives. First, we describe well-defined sets, subsets, universal sets, null sets, and cardinality of sets. Second, distinguish equal sets and equivalent sets. Next one, define subset and proper subset. And the last one, illustrate the union and intersection of sets and the difference of two sets. So this is our topic. It is all about sets. So what is sets? So sets, a collection of objects that have something in common or follow a rule. Take note of the word follow a rule or common. So when we talk about sets, just think about collection of objects or in other term, group. So when we talk about sets, it is a group of objects. But with a certain condition, and it says here, as long as the objects shares a common characteristics. It should share a common characteristic and for that to be well defined. So let's have an example of sets. The first one is a set of numbers from 1 to 10. So what comprises a set of numbers from 1 to 10? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The other one, a set of animals in the farm. So what are the different animals in the farm? For example, chicken, ducks, pigs, and so on. Next one, a set of Philippine presidents. So we have how many Philippine presidents already? We have 17. Okay, starting from Emilio Aguinaldo and then the latest is President Rodrigo Duterte. Next, a set of yellow flowers. What are the examples of yellow flowers? We have yellow bells. We have sunflower. Okay, and then next, a set of integers. Integers, we have -1, -2, 1, 2, 3, and so on. And then the last one, last example, a set of three-dimensional figures. What are the different kinds of three-dimensional figures? We have cube, we have rectangular prism, we have pyramid, and so on. So when we talk about set, it should have well-defined and it should have a common characteristics. So that is a set. Did you understand what is a set? Okay, good. So try this. State whether the following elements form a set or not. If not, give a reason. We look at column A. Collection of positive integers. Is that a set? Yes, because the condition is well defined, which is positive integers. Next one. Collection of math books in a library. Is that a set? Is it well-defined set? Yes, because it says here, math books in a library. It is specific. Next one, collection of names of student in a school. Is that a set? Yes, that is also a set. Next, collection of animals weighing at least 300 kilograms. Is that also a set? Yes, because we have a specific condition which is at least 300 kilograms. We proceed to column B. Collection of rich people. Is this a set? This is not a set. Why? Because rich people we didn't define. We have different definition of rich people. Rich people is very broad term. So we need to specify it for it to make it a set. Okay, did you understand? Next one, how about the collection of large animals? This one also is not a set. Why? We didn't define the word large. Again, it should be specific. Next one, collection of nice objects. This one is not also a set because you didn't define again the word nice. This one. And then the last one, collection of bright students. What for you is bright students? For me, bright students are the one who are learning and not bookish. And maybe for you, bright students are bookish. So we have different definition of bright students. And so collection of bright students will not define a set. Next. So how are we going to write set? So set is written in capital letters. And it includes pair of braces, commas, and the description. Every object is in a set is unique. Take note of this one. Every object in a set is unique. Unique means the same object cannot be included in the set more than once. For example, in a set of numbers from 1 to 10, it should only have one number 8. Okay? So, if you have two number 8s, you remove the other 8 already. Because it says here, every object in a set is unique. Did you understand? Next. The objects, which may be countries, cities, years, numbers, letters, or anything else, are called the elements of the set. So, the objects in a set is called elements. Okay? It is elements of the set. Let's have an example. A is the set of the first 6 letters of the alphabet is, okay, this is how are we going to write it. So A is equal to, what are the first 6 letters of the alphabet? We have A, B, C, D, E, F. Okay, question. Is each elements in the set is unique or not? Yes, they are all unique. Okay, nothing is repeated. Okay, next one. So, the elements of set A is A, B, C, D, E, and F. Next one. These are set of, what do you think is that one? 2, 4, 6, 8, 10. This defines a set, right? Or what is the specific condition that defines this set? 2, 4, 6, 8, 10. They are even numbers. Therefore, this is a set of even numbers. Very good. Okay. So, it is the set of even numbers between 1 and 11. If we say between, are we going to include 1 and 11? No. Because it says here between, it is in the middle. And then 1 and 11 are not even numbers. Did you understand? Okay, very good. Next one. Set A. What do you think is that one? Okay, these are set of primary colors. Set B. This is, I should say, set of hands. And then set C, we discussed that a while back. This is a set of integers between 1 and 9. Okay, very good. So we have three ways in describing a set. Number one is roster notation or listing method. Listing each element of the set inside the braces. And then letter B, verbal description method. Describing a set in words from the word verbal. And then the last one, set builder notation or rule method. List the rules that determine whether an object is an element of the set rather than the actual elements. Okay? So list the rules that determine whether an object is an element of the set rather than the actual element. So you are going to write the rule why that certain object is included in that set and not the actual elements. Did you understand? Let's have an example for you to better understand it. Letter A. Set A, I should say. The verbal description method. Set A is the set of primary colors. Listing method or roster notation. So set A is equal to followed by the curly braces, and then you are going to input the different primary colors. We have red, yellow, and blue. Did you understand? And then at the last part, it should be the partner of the first curly braces. And the next one, set builder notation or rule method. So A, set A, curly braces, and then X such that X is a primary color. So X here, you need to define what is X here. So X is the primary color. So we're going to read this one as the set of all X such that X is one of the primary colors. So we go back to the definition of set builder notation for you to understand it. In set notation, set builder notation or rule method, you are not going to write the actual elements. Did you understand? Instead, you are going to write or list the rules that determine whether an object is an element of the set. You are going to write the rule. An example of that one is in set A. So we know that set A is sets of primary colors. So therefore, set A is equal to X and then cut by X, wherein X is a primary color. So you need to define what is X. X there is the element. Next, we proceed to cardinal number. The cardinal number of a set is the number of elements in the set and is denoted by n parenthesis A. So let's have an example. So let's set A equals 2, 4, 6, 8, 10. So what is the cardinal number of the set? Then A is, parenthesis A is equal to 5, and we can read this one, the cardinal number of A is 5. So when you solve this symbol, we read that one as cardinal number. Did you understand? Did you understand? Okay, very good. We proceed to the next one. So we have the different kinds in representing a set. Listing or roster method, verbal description method, and then set builder notation. For example, number 1, set V is equal to A, E, I, O, U. This is a roster method. Verbal description method. So V is the set of vowels of the English alphabet. And then set builder notation, X, wherein X is the vowel of the English alphabet. Number 2, D, set D is equal to Tuesday and Thursday. What is the verbal description of the set? So D is the set of days that begin with T. Set builder notation, D is equal to set, is equal to X, wherein X is a day that begins with T. Are we okay with that one? Did you understand? Another one, set C. We have 1, 2, 3, 4. The verbal description method, we have C is the set of counting numbers less than 5. When we talk about counting numbers, the numbers that we are counting, are we going to include 0? Is that a counting number? No, it's not. Next, set builder notation. C, X, wherein X is less than 5 and X is an element of N. Okay, I'm going to discuss this one. X is an element of N, and here is the symbol for integers. We all know that 1, 2, 3, 4 are all integers. So X is an element of N. Did you understand? We have two conditions. It is less than 5. Tama? Right? And the next, X is an element of N. You need to define that these are integers. And then last one, 4, we have set L is PSALM. So verbal description method, we have L is the set of letters in the word Psalms. And then set builder notation, D, wherein is equal to X, wherein X is a letter in the word Psalms. So we now proceed to the different kinds of sets.